All right, so this video is just a few quick examples of how to convert either between slope-intercept form or standard form, um, how to interchange between the two, right? So for example, here we're being asked to convert this function, this equation here, from slope-intercept form, which is what it's in, y equals mx plus b, from slope-intercept form into standard form, ax plus by equals c, right? So let's go ahead and do that. So all we're really going to want to do, let's go ahead and rewrite so I can mess with this over here separately. All we really want to do is understand that a, b, and c are integers. They're whole numbers, okay? So for example, this fraction right here representing my slope, m, is unacceptable. I need that to be a whole number, an integer, right? And I can easily do that by doing a useful trick that I've shown a lot of my students. If you've got a fraction and you want to get rid of it in some kind of equation or other context, all you have to do is multiply by the denominator of that fraction. Now, the thing that always messes people up is when you do that, right, I can't just multiply only this term by this denominator. I've got to multiply the entirety of the equation, every single term in the equation, by 2. So I've got 1, 2, 3 terms. You can always tell what the terms are because they're separated by either a plus or a minus, okay? Or it's just kind of a standalone the way y is here. Okay, anyway, I'm going to distribute a 2 into this entire equation so that I now have 2y is equal to, and let me illustrate a little bit what it is that's going to happen over here. So I have 1/2 x multiplied by this same 2. Well, that's just 2 over 1, right? And what I'm going to end up with is 2 over 2 times x, which of course is just effectively x, right? So now I've gotten rid of this fraction and I don't need to worry about it anymore. And that is a step closer to satisfying the criteria for being in standard form. And after I distribute to there, I also have to distribute to this 4. So that becomes x plus 8 now. And I'm almost there. All I need to do now is understand that this c, right, is a constant. So you can think of it as instead of having the y, the dependent variable by itself, we want to have c, the constant, by itself. And that's exactly what I'm going to do. I'm just going to do minus x to both sides. There is no x term here on the left, so I have nothing to combine it with. This 2y is positive. So what that's going to translate into is negative x plus 2y equals 8. And for all intents and purposes, we're done. Depending on what book you read, you may read that this leading term cannot be negative. The leading coefficient cannot be negative. If that is the case, right, all you would want to do is distribute a minus throughout this entire equation, right? So all I would have to do in that case is change the sign of everything. So this negative x becomes positive x. This positive 2y becomes negative 2y. This positive 8 becomes negative 8. Okay? If you're in my class, this is acceptable, but this is also acceptable here. Okay? So now let's look at going the other way around. So let me erase, give myself some room. So now we've got an equation that here on example 2 is in standard form, and we want to convert it into slope-intercept form, right? And we notice the key difference again. Here we have the constant by itself. A and b are integers, whole numbers. And here we have y by itself, the dependent variable by itself. M and b, we don't really care if they're integers or not, okay? Just like what we see here in this OG example. So let's go ahead and take this guy and convert it into slope-intercept form. So I'm going to rewrite, give myself some room, probably start up here. So 12x plus 4y is equal to 16. Okay, so what I want to start doing is trying to get y by itself, starting to isolate y by doing inverses of everything around the y, right? So everything on this side of the equation. Okay, so I'm going to do minus 12x to get rid of this positive 12x. Okay, and right here, I can rearrange these two terms. I can go ahead and flip-flop these guys, but they have to keep their signs. This negative 12x, this minus 12x, that's a negative 12x, right? This 16 is a positive 16. So when I flip them, it's going to look like this, negative 12x plus 16. Okay, now I've got this multiplication by 4 here that's not letting me have the format that I'm looking for, specifically where y is by itself, right? So all I need to do is divide by 4. Well, again, we have to be careful how we do this. If I divide this guy here by 4, I have to divide everything else by 4, okay? So seems simple enough. Y equals negative 12x plus 16. All of this over 4, right? But we can also say that it's each of these terms individually being divided by 4. So we can say it's negative 12x over 4 plus 16 over 4, right? And now it becomes pretty obvious how we're going to get into this format. Y is equal to, well, this guy here will reduce into just negative 3x, and this guy here will reduce into just the plus 4. Y equals mx plus b. And we're done. That does it for this video. If you have any questions over anything from this video or anything else math related for that matter, you know how to reach me. Shoot me an email or come find me. Goodbye.